So the experimental setup for determining the optimum process parameters required to achieve desirable response variables. This is the problem statement, and we need to find out the optimum process parameters that is responsible for obtaining desirable variables at the output. So first, since our project is on design of photochemical machine, so first this is the general experimental setup that we considered. You can select different process parameters for different process. For example, for drilling, for machining of using CNC machine, etc. So you can change the experiment, but the procedure of analyzing the optimum process parameters remains the same. So in the first stage we designed a photo tool for our project. That's the next stage comes the design of experiments. So in this stage remains the same for every processes, be it a drilling process, be it a photochemical machining process, be it any machining process, any boring process, etc. So the process parameters such as concentration of etchant, etching time, etching temperature are considered. Taguchi's method for design of experiments is adopted. Okay, so how we adopted this is, first we need to consider three levels or any other levels. I assumed as 3, 1, 2, 3, and I assumed these three values of all the process parameters. Then we go to Minitab software. This is a display that comes when you click on the software. Go to Stat, Design of Experiment, Taguchi, create Taguchi design. Now here is 2-level design, 3-level design. Since we have 3 parameters, then we go for 3-level design. Number of factors, we have 3 factors, that is concentration of etchant, etching temperature, and etchant time. Then we go to display available designs, and we'll get 9 combinations. So we'll select L9, 2 into 2, 4, 3-level process parameter of design. We've selected that array, then click on OK. Please specify the design. OK. Select this, go to design, select this design for 9 combination. Okay, 3 into 3 matrix will be generated here. So click on OK, and you can see here, see the level. This is the matrix that is generated. We go to Stat, DOE, modify design. Modify factors in inner array. Specify. For A, that we considered concentration of ferric chloride. So we copy it and we'll paste it here. Similarly, for all this, etchant temperature, Control V, etching time, Control C, Control V. Okay, 40, 50, 60, Control C, Control V. Okay, so if you type it 40, 50, 60. Okay, what is the other values? 45, 60, 75, 45, 60, 75, 35, 45, 70, 35, 45, 70. Okay, see, these values got changed in the table, and you get 9 parameters. Okay, 1, 2, 3, 4. This is the combination of processes that you will experiment it. So after this level of process parameters, we found out using Taguchi's design these 9 combinations of process parameters. Okay, then we have to find out this is for each combination we need to find out these response variables out of experimentation by performing experiments. For this, these are the MRR values, that is material removal rate and surface roughness values. For this experiment, these are the values, etc. So we plot a table after that. Then comes the response optimization. Since there are two response variables, that is MRR and surface roughness, then we need to normalize these two values into a single value, that is gray relational grade value. So this is, there are certain steps that you can see, you can search on that, and you can find out the procedure to follow to get these values. Let me show you. So these are the formulas, and because with using these you get these values. Okay, so after that you need to, after experimentation, you need to put these values in that table. So we'll go to that table and write material removal rate